My name's Alan Leframboise. I'm here with Mark Torrey, and today we're going to take you through spatial analysis for developers and give you like an overview of the different capabilities and the different possibilities that you have for developing with the spatial analysis technologies. And our goal is to give you a number of tips and tricks too along the way. So we'll start with just spatial analysis. So we define it as the process of using analytical techniques and calculations to find relationships, discover patterns, and solve problems. Ultimately, if you're building an application to perform spatial analysis, then typically you're looking for patterns in the data, and you're looking to solve some sort of real-world problem that's based on data. And ultimately, your goal is to build an application that answers a question. The thing that is important to realize is that spatial analysis is often a process. And what that means is it can be iterative. Sometimes we don't get all of the parameters set quite right. Sometimes we have to do it over and over again to come up with a good set of parameters that work for the data. So we're going to talk about that too, and we'll talk about how important the data and the type of data, the role that it plays in performing spatial analysis. So the different types are listed here. We're going to cover these 5 from geometry down to routing analysis. So this should be something for everybody. So just a quick show of hands. Is there anyone in the audience that has experience, using our spatial analytics tools, either Map Viewer or ArcGIS Pro? Okay. And what about just building different applications, calling our REST endpoints to perform spatial analysis? So some folks do. Okay. All right. Okay, so to perform spatial analysis, really 5 steps that we're interested in. The first is preparing and finding data, and that's something that we can't underestimate because you can't perform an analysis unless you have something to start from and perform an analysis on. So that's the first step, and we'll give you some tips and tricks here along the way to show you like where you can find data and how we can actually even create data that we can use for different analysis. And then selecting the kind of analysis. So is this something you want to do client-side in your application or server-side? Do you want it to be sort of a short process using a direct service API? Or will this be a long process because it will process against maybe a large data set? Perform the analysis, display the results, and then of course evaluating the results. And that's that iterative part I was talking about. So one of the tips that I have just to kind of kick us off is the more you use the ArcGIS tool suite to pre-perform the analysis, then the better off you are developing the application, or the easier that makes developing the application. So we can use the Map Viewer and ArcGIS Pro, like I mentioned earlier, Scene Viewer, Online, all these different things. So Mark's going to start off by showing us a demonstration on how to take advantage of some of the tools and some of the things we can do.
Yeah, thanks, Al. So what we've got here is just the out-of-the-box map viewer, and I've added a sketch layer. So this is a layer that is actually persisted in the web map itself. And so we can use this to generate geometries, right? So we just use the geometries to create new geometries. Again. And save that. And then what we can do is actually, those geometries are persisted in the web map itself. So they're not backed by any kind of feature service or data service per se. They're actually saved in the web map. So we can actually hit the REST endpoint, use the sharing API, pass in the item ID of our web map and ask for its data. And we can see that our sketch layer here is saved in this feature collection. All right, we have all the drawing info and the feature set, and you'll notice I have those 3 features that I just created, geometries available that we can then use in the future, right, to do it. So the raw REST is a little bit, I wouldn't say difficult, but harder to parse. So I also wanted to kind of show off this tool called the ArcGIS Assistant, which is a tool that Esri Professional Services developed to to allow you to kind of view the content within your portal. So what I've done is I've signed in to ArcGIS Assistant. I can look at this geometry analysis web map that we just created, and then view the JSON of that data, and then look at the data itself, and then our geometry is right there. We can just grab that geometry and use it in a, we'll see it later on down the road, but it's a kind of a quick and easy way to use existing tools to generate the geometry that we can then iterate on later.
That's perfect. Yeah, so this is really handy. There are a lot of times, and it's hard, generating the UTM coordinates for even just like a simple square or a polygon that you have. So this is just a quick way if you need to get a geometry and the coordinates and grab the JSON and move from there. Is that it?
Yep.
Cool. All right, so that's our first tip of the day. Let's start and just kind of extend that into geometry analysis. So we're talking about working with points, lines, and polygons at this point. And so basically the different operations you can perform with geometry all occur on the client side in this discussion. So we're talking about either a geometry or projection engine that resides in JavaScript.NET or any of the Maps SDKs you can see on the right-hand side there. We can also use Python for this operation. And then there's no auth that's required, which is great because it's all client-side. And then, so it doesn't matter what type of developer you are, platform, online, enterprise developer, it's easy to perform these geometry analysis. Again, it's all in the client-side library. So spatial, it basically breaks down to categories of spatial relationships, calculations, length and area, and projection. So the process for performing geometry analysis means that, sure, you need to create a geometry. We already have a sneak peek on how to do that. Choose the operations that you'll join together, perform the analysis, and then display the results. So you can see the code illustrates that, where we have a geodesic buffer, and then we do a from JSON. Again, this JSON we could dump in from the process that Mark just showed us. Pass in the spatial relationship, and then we perform an intersect. And that's the little diagram you can see up top here. So that's an example analysis. So geometry analysis is the process of joining multiple single operations together. So I'll pass it over to Mark.
Okay. Okay, thanks, Al. Yeah, so as Al mentioned, we have a plethora of geometry operations that we want to show you, and the best place to learn about those is the developers documentation site. So I've just gone to developers.arcgis.com, hit the documentation tab, and into the mapping APIs and location services page. So you see we cover a lot of topics here, but specifically we want to look at spatial analysis and then geometry analysis. And to kind of reiterate what Al just mentioned, right, these spatial relationship operations in the geometry analysis is what we'll look at first. So, we have these different operations, how those relations are. And it's also important to note that the geometry, these spatial relations and operations actually require one or more geometries, and are usually like a test to see if an operation exists. And then if that operation exists, we can chain these together and perform multiple operations till we get our desired outcome. So we'll kind of jump just through these to show some code and some samples. So starting off in spatial relationship analysis. So this app here is really kind of cool to really demystify how the spatial relationship operators work. So essentially what we're doing is we're testing to see if two geometries, what their relationship are to one another. So you notice as the application initial load state comes up, right, we see that the polygon is disjoint, meaning there really is no relationship between these two geometries, is true. But as we move this geometry around, right, we'll notice that intersects pops up, and then as we're inside that geometry, the contains becomes true as well. And so the order that your geometries are being tested is important too. So if we, add a, let's add a line here and a polygon, right? You'll notice that those certain operations become not available, right? Like a line cannot contain a polygon, so that's not even going to be tested. But we do know the line crosses the polygon and the line intersects to true. And so this is a really cool application. If you ever have some quick relationships that you want to test, here in the lower left-hand corner, you can always go out to CodePen. There's a CodePen link here that'll take you out, and all the code is available for that application for you to play around with.
I think what's really interesting here is that these are just Boolean operators. So basically, the result of testing your relationship, whether something is within or touches, is just a simple Boolean value back. So that's this whole category versus other categories that give you geometry back and so forth.
Yeah, so we'll see each of these kind of types of specifically geometry analysis are different operations that return different things, right? Well, spatial relationships are Boolean operators. We're just doing tests. And some of those, as in the documentation, as we scroll down, right, each of those specific operators we have documented with all the client apps, client APIs, excuse me, and also code for Java, right? If we expand it, we can see what those methods look like for each of the SDKs and APIs, right? And we can look at each one, how those would actually run. Disjoint, overlap, touches, relate. Okay, so spatial relationships, those are Boolean operators. And then if we move into geometric calculation, right, these are operations that are actually going to result in a new geometry. So again, we have a pretty cool app here to test for the different operations of geometric calculation, right? So if I choose buffer, right, this point gets buffered, and that's purple polygon there is the result of the buffer. And we can go through, right, intersect, right, these two geometries. The purple area there represents the new geometry that gets calculated from that.
So again, these are all client-side, done
Correct.
in whatever engine that you're using environment. So like I said, the Maps SDKs all have a geometry engine that you can access and make use of.
Yeah.
So.
Yeah, and this is a cool one too, is the nearest vertex, right? So as we, refresh that. Move here to nearest vertex. Oh. All right, and nearest coordinate, you can see the differences. The vertex are where those two lines connect, and the nearest vertex to our input point is this top right one. And again, just like all the other examples, hopefully you kind of see a pattern here, right? We have examples for each of the operations in each of the SDKs. You also notice one thing I kind of want to point out here is the Python sample, right? We actually are, I know we mentioned or specified that these are client-side operations, and that is true in Python as well, but also we can do a check to see if we have ArcPy installed, we can do this operation client-side. If it's not installed, then we can use actually a server-side operation and buffer the geometry through the geometry service. So it's, you just want to be aware of kind of where these are running from. And again, Swift. And then just to touch on length and area, right? It's important to distinguish between geodesic area, right, what a geodesic area and a planar area are. So a geodesic area would be the area around a spheroid, essentially, and then the planar area would be like a 2D, just XY, essentially, distance and area between those two. So again, code samples throughout. I won't belabor it too much, but one last thing that is pretty cool is projections. So projections play a huge role in how these geometries are created and used. You notice we have this application here, which contains a 3D representation of our geometry. And then we see the geometry as it exists on the map, the 2D map. And as we move toward the poles, right, on the 2D map, that geometry really gets stretched. But on the 3D map, right, it remains static. And we can change, you know, which projections we use, so we can test what is actually getting preserved in which projection for our specific use case.
This is a good app to measure like how disproportionate things are, you know, so it's really important.
You can kind of see what the different. Cool. Yeah, so just one more, going back to our little example here, right, where we take, I just wanted to finish this one off, where we take the features we created in the map viewer, and let's say I have my polygon here, I want to create another polygon. I'll save that, refresh to get the new data from the web map, find our features here, and I want the second one. I'm going to grab the second polygon, and then we've got a little app here. I can just take that right from the web map and into my app. And then, you know, in our JavaScript API app, we have that polygon that we created in the map viewer. So we didn't have to kind of programmatically create it. We were able to use the tools to do that.
So are you doing the geometric test to see if that's within?
Yeah, so
it's passing and it's purple.
Yeah, that's a good question. So you'll notice here we're actually doing the test here using the geometry engine. So we take the geometry engine, run an intersect, these two polygons, that returns the intersected geometry, and then we can display that new geometry. Right? So that's our new geometry from these two existing ones. Cool.
Okay.
So back to you.
All right. Okay, so moving on. So that's geometry analysis in a nutshell. And let's move on to 3D visual analysis. So there's many different flavors. So the three that are the most common for visual and 3D visual are client-side API calculations that involve line of sight, one place to another, to see if there's obstructions between the two places. Viewshed is kind of the entire area that you can see from a target location, and then length and area is another type of calculation. So you can see the APIs that are that you can use to perform these client-side on the right-hand side, and again, no API key authentication or anything is required. So when it comes to 3D visual analysis, it's really 4 steps. So we define the scene. So you need some sort of topography or some sort of elevation model as input. And then the other input typically is an observer and a target. And this is often used, as you can see, we're looking into Yosemite Valley here from El Capitan into the valley. And the red part is the area that is basically obstructed, and the green part is what is actually visible. So then you perform the analysis and display the results. So our code here, again, is creating the observer, then creating a target, and then at that point you run your analysis. So, yeah. Mark, what do you say?
Yep. let's do it. So, yeah, again, so as to kind of reiterate what Al just mentioned, right? And hopefully you're kind of seeing a pattern here that we have the examples for Viewshed, right? Specifically, Viewshed at a certain elevation, right? Again, all the specific code that's supports 3D analysis, 3D visual analysis we have available, right? A specific analysis of what's visible to the camera, and then what's visible based on geo-elements. So in this case, buildings, what cars are visible to a building as it's driving down the road. And again, you know, the code is all available for the SDKs. So that's Viewshed, right? Line of sight, as Al mentioned, right? We can create a line of sight to see what's visible by creating a new analysis, and maybe we're down here in the valley and we want to see what's visible, right, from our position. You notice as I change elevation and move kind of past this ridge, right, things that are red are not visible to the observer, and things that are green are. And then last but not least is 3D measurement. Again, as you're, you know, standing here and want to measure the distance to the top of the Eiffel Tower, you can do that as well. Or measure areas. Right there as well. And this is just using the JavaScript API widget. So to show kind of in action as a developer, right, I'm going to leverage the tools again, and I've got this scene here of the Moses Cone Memorial Park. So I'm from the East Coast. This is in the Blue Ridge Mountains. It's a kind of a cool area where we like to go hiking, a family. So say we're down here and we want to, I don't know, maybe there's some tree maintenance that we want to do so that the mansion up here on the hill has a better view of the lake down here and all the trails around it. All right, so we can come in, use the line of sight tool within the scene viewer to create these lines. You know, again, just like the other example, right? What's visible, what isn't from this target position, from this observer position to this target position. Right, and if we stop that, done, save. Again, we can take that scene item, right, pop it in, get the JSON for it, and this will give us right, all the information for those inputs we just added, right? So the observer position, the targets.
And then I imagine you could use those in an application, just grab it.
Right, yeah, so then I can take that same item ID, and if I go over to our application, I'm just going to bring in, you know, again, in this case, this is a JavaScript API. I'm going to pop that item ID right into the web scene, and now, you know, this is just a simple viewing application, but, you know, all those observers and inputs that I just put in now are available in my application.
That's cool.
And so I can take this now as a starting point and then maybe use some client-side geometric operations, right, to maybe buffer these and create different geometries from these line-of-sight tools.
So I think it's a great example there where we're looking at, again, using the tools and the applications that come as part of ArcGIS to kind of help with the development process. It's definitely tricky getting these 3D points and like getting the elevations just right and so forth, unless you write a custom app to do that. So why not use
Yeah,
3D
just another note on that is the camera position. It's really nice to be able to get that from the JSON too. So
That's a
instead
great-
of having to manipulate, what that camera is set to and the tilt and the angle, that's all embedded in the web scene as well, and we can just use the web scene to pull that.
That's a great tip. Yeah. Yeah, so use the tools to help with your development process. Okay, now this is kind of a big topic. We'll cover some of the essentials here, but so we're kind of getting more and more complicated, I think, as we're moving through. So feature analysis is all about performing analysis on feature layers that are in feature services, and they involve multiple features. So with the geometry analysis, as you saw, it's typically just one geometry and compared against another, and then you can use that to maybe perform another analysis. But feature analysis is definitely more complicated. So it's server side too. So now we're moving from the client side to the server, and these analyses are all surrounded around the spatial analysis service. So that's an endpoint that you can access. It's one of our location services. It's in ArcGIS, and you can access it there. You can also create and expose feature analysis services through Enterprise as well. So here are the categories, find data down to calculations. So there's different categories, and we'll take a look at a couple different examples. So as far as the SDKs goes that you can use, basically the reason that the top ones are grayed out for the Maps SDKs is because there's not always a one-to-one relationship to a class and a package available in the Map SDKs to all of the feature analysis. But what you can do is you can always use a request and then format the parameters and then communicate with the spatial analysis service. Unless you're using Python or the REST API directly, then there are wrapper classes to communicate with the backend service. So that's important to note. The other thing too is you can't use API keys. You need to use OAuth 2 authentication to get an access token. And then this is for online and enterprise developers. Okay, so the general steps to create and find a feature layer. And then like I was telling you before, like you need input, you need a feature layer to come from somewhere. And then perform some sort of analysis. And these are long processes, long job processes is what they're called. They used to be called async, but now they're called job. So if you see the word job operation, that basically means there'll be multiple calls to the service to process this request. And then we display the results when we're done. So here you can see an example of traffic crashes. This is in Python. So we set up a fishnet as the type, and we're going to find hotspots against this point layer, and you can see the results up top. And what it takes is as an analysis layer in, fishnet is the shape type out, and then what we do is we query the features and then display those to the screen. So yeah, let's take a look at a couple examples, and yeah, we'll go from there.
Okay, yeah, so back to our spatial analysis chapter here, and we're under feature analysis. And again, we've got each of the feature analysis broken down by a specific category, right? Finding data, combining data, summarizing data, analyzing patterns, and calculating geometries. So I know in the first part, we saw calculating geometries, just one or two geometries, but say we have 100,000 geometries that we want to create buffers on all at once and use that. So as Al mentioned again, these are all server-side processes, right, as opposed to the client-side processes. So that gives us the ability to process a lot more data. So we'll go through a couple of the examples here again as well. All right, so find existing locations. All right, so we've got some parks here and some bike routes, and we want to see all the parks that are within 150 meters of a bike route. So we run the find existing locations, and that processes on the server, comes back, and then our results come back, and we can see, oh, this park is outside of that zone, so maybe we need to notify the city and let them know they need to build a bike route next to this park as well. And you can see we're kind of zoomed in, but the part, we can process a larger amount of data, right? with that process. Yeah, so let's keep going. So the finding data, combining data, this is a pretty cool one. So we want to overlay, right, this data. So we have a feature layer of the real estate parcels and a feature layer of the flood zones, or maybe this was a flood phenomenon that occurred, and we work for an insurance company and want a quick way to grab all the parcels that were affected by the flood. We can run overlay analysis on these two layers, and this will pull back and give us all those parcels that were affected by that flood zone, or in that flood zone. Maybe we can adjust those rates of the houses there.
I think the important thing here is that this is actually a new feature layer. So it's not just a client, it's just not a client-side query. This is a brand new feature layer. It's going to have an item. It's going to be registered in your portal. And you do have the option programmatically of just returning the JSON if you want, but it's a lot of JSON to handle, right? So you're better to let the system create a feature layer, and that's probably a good tip and a best practice.
True. Okay. So a couple more. So summarizing data, right? Being able to kind of aggregate data and make it easier to kind of derive decisions from. Right? In this case, we have a point feature layer that represents the breweries across the country, the number of breweries, and you can kind of see, well, we've kind of got them scattered across the U.S. We've got some pockets we can see, but if we run an aggregate points analysis on this data, we can actually aggregate the number of breweries per county. So as I slide to reveal the results of this analysis, you'll see it really kind of starts showing us the trends in the data, right? So the West Coast, right, lots of breweries. The Northeast, right, the breweries are popping out there. And
so Mark, did you write this application for any particular reason, or?
No, just interested.
Okay.
Yeah. And again, so we have all the code samples for those, right, in Python and ArcGIS REST.js. So what you notice are the Maps SDKs, right? So these are server-side operations that we're running, so the code samples are a little bit different. But we just essentially have it in Python and REST.js. I think this summarized center and dispersion is interesting, kind of adding in a little bit of the statistical analysis that we can perform on these geometries. So we've got a feature layer of beetle infestations, and we can run a summarized center and dispersion, and that'll give us the kind of the statistical grouping of this data, where kind of the mean and the median of the infestations occurred, and then we get the ellipsoid to kind of show the trend of which direction that analysis occurred. Again, we've got the code there to apply as well. Just a couple more I want to show. We mentioned earlier about creating new data. The server-side operations are the same, and so a lot of times if you don't have existing geometries, or maybe you can't use the fidelity of your census blocks, you need some sort of geometry to create. There's a generate tessellations that will actually create these feature services for you, right? And you'll notice, we can create both bins, right, based on a boundary, hexagon bins and square bins, right?
These are really handy if you have point data and you're looking to see where there are clusters of point data and you need to put them in little buckets, then this generate tessellations is super handy.
Yeah, again, if you guys take a look at the actual code that we have here, a lot of it is really kind of goes back to what Al mentioned at the beginning, that process, right? You pass in the data, find your operation, submit it, check on it, and then come back. is fairly consistent throughout all the feature analysis. Okay, the last one here I want to show you is the traffic crash hotspots. Right, so again, we've got a large data set of traffic crashes, and again, we want to see, what the significance is of those and what the confidence is of the clustering of the crashes. And so through the hotspot analysis, we send that to the service, and we get, confidence, which is, pretty what we'd expect, right, in downtown areas where the majority of those traffic crashes occur. And again, right, the code. So to finish up here, I just kind of wanted to go back again to using our tools to show how to run these. So I've got those traffic crashes here loaded into our map viewer. And if I go to the analysis tab, I can actually run a process here in map viewer. Actually, before I start this, let's do this. And I'm going to choose our crashes, and maybe we want to do point counts, and how do we want to aggregate these and process these. We'll say maybe hexagon cells. We can set some other properties here. What we want the cell size to be. We'll just use the defaults, and then let's give it a name, an output name. And then we can actually estimate how many credits that'll take to run this operation. I'm going to go ahead and kick it off, and you'll notice we look here. Here's our submit job.
So this is a nice way of kind of learning how to perform these operations programmatically, is to actually use the tools and to follow the network tab like Mark's doing. And so you'll see there's typically three operations. So we're going to submit the job originally. So that was the first request. And then the system's going to come back and check the job. So it's going to iterate and with the job ID. And then once the job is done, then we can fetch the results. So it's really, that's why it's called a long job process, and it's different than the direct request.
Yeah. Sorry, I kind of got ahead of myself, but I also wanted to show you, kind of that step Al just mentioned, right? We get the analysis URL that's associated with our organization. We want to make sure it's performant, it's close to our data, and so we can ask the portal for its analysis URL. And then once we have that, we can then send it, right, with the submit job, then check the job status as it's running, right? So it'll be executing, then once it's done, it's going to give us the results, the new feature set that was created, and then we can go fetch the actual item that's returned. All right, and we'll check on our process here. All right, so he's still running. And if we look at one of these guys, right, we can see our task is still executing. So that's kind of a nice way through the map viewer. We've also got a Postman collection. So if you didn't want to run curl or HTTP on your system, you can go out to our location services Postman collection. I should have had this up. So if you go to postman.com, Esri devs, right? We have a big collection of pre-created workspaces and requests, and these are scattered throughout the documentation as well. So if I go back here, you notice we have a little note, hey, you want to run this in Postman, you can do that, right? And so there's a good getting started section, right? There's a little bit of setup that you need to do to perform these in Postman. So you create an account, you fork the collections, and I've already done that here, so I have these collections forked on my local system here. I'm going to send a request to get a token, and then I'm going to run through that 4-step process that we showed. I'm going to ask the portal for its analysis service. So if we look in this big hunk of JSON that comes back for helper services.
And this is interesting about the spatial analysis service. It's one of the only services we have that we actually don't publish the location service endpoint, because for every portal, the endpoint could be slightly different because it could be in a different cloud cluster that's more effective. So typically, you notice, like for geocoding and routing and places and everything else, you can just go grab the URL. This is one where you have to actually make a preliminary request to your portal. So that's what Mark's showing us here. And once we get it, we can extract it and then put in our operation, and we're good to go.
Yeah, right. So there's our analysis URL. And once I have that, then I can do the submit job, right? Make sure we've got a token. Our analysis URL looks good, right? We get that job ID back. And now we can start checking the status of that job.
So unless you're using an API, you have to check the status yourself. So he'll have to keep clicking that button.
Pinging this guy until he's done.
One of the benefits of using REST.js as a library. So I actually have a session on that tomorrow if you guys are interested. We show how to use the job process that really makes this a lot simpler.
Yeah, so just going back to that, you know, as Alan mentioned, the REST.js, right? It really simplifies that process where we can just send the submit request job with our parameters and then listen for those messages to come back. And we get the response back from that.
Cool.
All right. So, yeah, okay, so our map viewer, right, finished. You'll see we get the results back. What's also interesting is we get that live, the feature service back that includes the rendering and drawing information, right? So those are included in that new feature service, which is kind of nice. So we don't have to kind of hand code the symbology for that.
And of course, that renderer that we're looking at here, so that wasn't the map viewer doing that. So the map viewer was receiving the render instructions as JSON from the service and then just applying it at runtime. So if you're using any of the Maps SDKs, then it makes it really easy. You just grab that JSON and you can apply it as a renderer. If you're using open source libraries, then you have to kind of hand code that yourself. So.
Yeah. So just real quick, just showing the results that came back. All right, we get the URL to our new service and the item ID. So
cool.
Handy. A couple different ways to do that. Okay.
Okay, so yeah, feature analysis, a big, large topic. We could have definitely spent the whole hour on that, but I encourage you to refer to that spatial analysis chapter that Mark was pointing to there to get the code and take a look at some of those samples. A couple of two other types of analysis we're going to squeeze in here. So data enrichment is also another type of analysis that involves, you know, learning about local facts and demographics. And this is using the GeoEnrichment service. And again, you can do kind of larger processes or smaller processes with this. And it's all about making proportionate calculations. And that's why the GeoEnrichment service is so powerful. So if you have an area, whether it's a regular area or an irregular polygon, you can see that when we're determining like what the average household income is or something in an area, then we have to use this proportionment algorithm. And that's what's built in to the GeoEnrichment service, and that's what makes it so powerful. Not a lot of the SDKs have client-side APIs that map to the server-side REST endpoints. So typically we use Python REST calls directly or ArcGIS REST.js as well. And they make it really easy. So you can use API keys, OAuth, and this is for platform and online developers. So 4 steps. We create or find a feature. We need to pass a feature in. That gives us some context to start from. Then select the analysis variables, perform the analysis, and display the results. So You can see an example here of REST.js, and we just look for, in this case, we're just using the defaults that are returned back, but we pass in a study area, which is a point, we use authentication, and we get some data back. So hand over to Mark, and he'll show us some examples.
Yeah, so really quickly, we'll talk about the GeoEnrichment service. So, you want to define a study area, what area we want to enrich. And I specifically want to kind of point out the analysis variables. This is a large topic, and so we've created these two tools that allow you to really go through and find, specific information, specific variables to use that you want to enrich. So maybe we want, meals at people that have their meals at restaurants, personal care products, budget expenditures, right? And so there's a lot of different variables available to us.
It's over 1,000.
Yeah, there's a lot. But you'll notice we actually get, as we select those, we get the URL that we can use to make that request with those tokens, with those variables appended. So to kind of show that in action, we've got some more apps, right? So the coverage area of the global data search, so that's data that's available globally, right? And so if we, run a quick demo around Sydney, we can click around Sydney, come on, and we get those variables back. Right, these are kind of higher level global population, males, females, kind of that, but we can get into specific local data as well. Right. Right, so around New York City, I'm clicking, and we get a buffer, 1 mile search. So that's our study area, and then we can get the median and average income, per capita income, aggregate income, right, that we can pull into our data, essentially, right, and use. So we can go back.
Okay. Cool. So last part for today is routing analysis. A lot of people don't think of routing as a type of analysis, but it certainly is, because there's quite an algorithm that has to do a lot of calculations against a linear network and make sure there's connectivity to get from A to B. So there's many different types of routing analysis that are possible. So you can just standard find a route like driving directions, or you can get optimized route, and there's actually a difference there. And then closest facility, fleet routing, if you have multiple vehicles and multiple deliveries. So we can calculate all of that. And in this case, you're going to use the routing service. There is another option of using the spatial analysis service as well. That's a little bit of a different story, but there are two services that can perform some of these long job type processes. So again, 4 steps. We need some input, typically starts, stops, and finish, location, the type of analysis you're going to perform, and then whether or not it's a direct or job process. So the API, it's one of the few APIs that we have that actually offers both. So you can just do a standard async call and get your values back and use a wait. Or you can use a job process, which is that 3-step process we looked at before, and then display the results. So here you can see just an example of REST.js where we have some stops defined, we have some params, and then we authenticate, and we're going to solve that route and have a handler to handle the callback information.
All right, so again, just some live examples of using the route service. And again, all the examples have a code pen link that you can click and get all the code for. But in this particular example, we're kind of showing the differences between an optimized route and a normal route. And so optimized route means that we're providing a best sequence so that the stops are actually sequenced so they preserve a specific either time or distance. And so you'll notice kind of the optimized route, right, is less time, and less distance. And these are interactive, right? So as we click, these new routes are being sequenced, right? And you can notice, you know, kind of we come in, then come out here. Again, the code's all there. Some of the other kind of, you know, the fleet routing is really interesting, right? So we're going to send a bunch of trucks out, and we want those trucks to take an optimized, you know, the best route to their stops. So they might have a collection of stops. So in this case, we have 2 trucks going out, or buses, in this case, making deliveries. And then again, code is all there, and the APIs are there, and the raw REST calls are there. So just to finish off, I just kind of wanted to show a cool little app our colleague George wrote in MapLibra that kind of pulls these things together. So using the GeoEnrichment service and the routing service, right, we can use the GeoEnrichment service to create a point, and that'll give us these analysis variables for that point that gets buffered a mile. And maybe we can zoom in maybe around LA would be a better. Right, so we can just do a buffer around a point, or we can combine the routing service, right, to create a 5-mile walk zone or a 5-minute drive area and see those demographic demographic variables associated with that specific geometry. So again, this goes back to, you know, using spatial analysis both to create geometry to use in spatial analysis and using spatial analysis kind of as a process. Right? So we can click around, and then we can also use the census blocks as the geometry. And we can come back over, we're kind of running short on time, to our analysis variable finder and pick some, maybe affordability index, right? Some of these, copy them, copy the JSON, go back to our app, and pop them in the analysis variables here. And that's going to parse, and you'll notice as we then click, we are getting results for those specific variables we just chose.
It's an awesome example, again, of using some of we call them tools. We call them ArcGIS tools. Sometimes they're apps. Sometimes they're bigger apps like the map viewer. This is a smaller app that got the analysis variables, but it defined that structure of the JSON with those analysis variables, drop them in the app, and then it makes it really easy. So yeah, it's pretty awesome. Okay, so just as a quick summary, so the different types.
Or use it on you.
There we go. Just as a quick summary, the different types of analysis we looked at today included geometry analysis, client-side, 3D visual, again, client-side, the feature analysis for the long job transactions, right? Where server-side, a little bit more processing, a little bit more coding there. Data enrichment, we saw that in action along with the routing analysis, and so many different options to perform routing analysis. So again, last tip of the day is basically, yeah, you can get all the source code and just learn more about the different operations that are available in the Mapping API Location Services Guide. And that's where a lot of these, actually, I think all the demonstrations except for the last one, all the code is available there in the different flavors of language. So if you guys like this, let us know. If you didn't like it, let us know. We'll make it better next year. And yeah, just give us a shout out. And I just want to thank you guys, and especially the folks online here too that stayed with us. And feel free to ask any questions. Any questions at all? Okay, then if there are no questions, yeah. Oh, there's one. Okay, so the question is there any way to add time to each stop? Do you mean like a delay? Like you... Yeah, absolutely. There's different ways that you can set those parameters, and there's definitely one where you can have a maximum and a minimum time per stop, and they can use that to stagger out all the deliveries along a route, so that you know, two delivery trucks don't convene. So absolutely, yep.
Yeah, all the parameters are on so on the documentation page, but then also on the REST API page, all the parameters list out there too, where you can kind of go through and see it's pretty heavy, the amount of parameters you can set.
Yeah.
Route.
The routing one, the fidelity is very, very high.
Yeah.
So yeah, I would be very surprised if there wasn't something that you actually couldn't do.
Yeah.
Yes. Okay. All right, great. Well, thank you very much. Have a great conference.
Yeah. Thank you.